Hi gang, we just did the product rule in the previous video, and I just wanted to point out that you can sort of see the pattern of the rule. So if you're taking the product of a function that has a multiplication of like 3 pieces, then it's the same idea. You just take the derivative of one piece, leave the other alone, the next piece, leave the other alone, the next piece, and leave the other alone. So you can sort of see the pattern to how it works with a product. We're going to go ahead now and move to what's called the quotient rule. And I always sort of smile to myself when I think of this rule, because when I first started teaching eons ago, and I gave a couple students a quotient, you guys are so clever at this point, being in calculus, you're so clever with the math, that I forgot that you could convert all quotients into products. And so I had a handful of students like do everything by the product rule, none by the quotient rule. So I now know that I have to write on your exam, must solve by the quotient rule on one problem, and then you're free to do whatever you want. But everything is like, you could just bring this up using a negative and it creates the product rule. So please do learn this rule. I will ask you one question. I will twist your arm and force you to do it this way. Only because I care about you, but you guys will outsmart me, and I have to, you keep me on my toes. So the quotient rule is when you have a quotient, then you use this rule, right? So here I have this fraction, I have this quotient, so I'm going to go ahead and use the rule. Now notice, again, it's not as simple as just taking the derivative of everybody and you're done. It doesn't work like that. So notice the rule. You take the bottom, you times it by the derivative of the numerator, minus the numerator as it is, no changes to it, times the derivative of the denominator over the denominator squared. So I'll get my pink pen out again here so that we can just be clear on when I'm doing the derivative. And I'm going to change the name of this guy back to H. Okay, Y is okay. Y is not an F. All right, so let's go ahead and do this guy. So in using the formula, as you follow me, this guy here on the top, this is F in terms of the formula, and this is G in terms of formula. Just to be clear, F is on the top, G is on the bottom. All right, let's give this guy a go. You'll notice the algebra is quite extensive in calculus. All right, so we take the G. Oh, and this one you have to do it in this order. It cannot be done in any other order because the minus sign has to be in front of the FG prime. So unlike the product rule, this isn't a free-for-all. It has to actually be done in a particular order, else you'll have this this backwards in the numerator. All right, we're going to grab G. No changes to G, just G as it is. G again's the bottom guy. And the bottom guy is x squared plus 1. All right, now we're going to take the derivative of f. So we have 4x minus 3. We're going to take the derivative of that. So derivative of that is going to be a 4, right? Derivative of 4x is 4. Derivative of constant is 0. So we get that. All right, here's the minus now from the formula. Now we take the f function, leave it alone, don't do anything to it. That's this guy. So it's just like the product rule, you do one, then you do the other, right? It's sort of like the flip, but you have to get the order in a specific way. All right, now we take G prime. So that's the derivative of this friendly guy down here. The derivative of x squared is 2x. Derivative of 1 is 0. Now you take all of G and you square it. I don't know how clearly you guys can see that. You take all of G and you square it. I'm just going to put it in a box. Nah, maybe not. You can put it in a box if you want, parentheses or brackets. Okay, gang, now that's the derivative. The derivative is done. It's just the simplification is the next step. I have to now make this look pretty. Alright, so now here's the simplification stage. I'm going to distribute the 4 to each of these terms. Be careful here because you're distributing a negative, so it's just easier for me to put the negative on the 2x. So when I do this, I'm going to think of this as being like a negative 2x. So negative 2x times 4x is negative 8x squared. Just you have to make sure everybody goes opposite as you multiply it by this. Alright, and then this times this is negative, but negative negative is positive. Okay, you don't want to FOIL out the denominator. Alright, let's combine like buddies, like terms. Let's put it in descending order. Just as a general reference, though it won't happen very often, my brain looked at the numerator and was like, oh, does that factor? If I take out the common factor of the negative, does the rest of it factor? And my brain got a no. But you still go through those steps because every now and then, every blue moon, this will factor and it may reduce, and you have to make sure you keep your answer in lowest form, okay? So just at the very end, always just check, does that factor? And if it does factor, is there a step after that? Because eventually in the later chapters, we're going to be solving with these, and so you have to be able to algebraically manipulate them. All right, so again, my comment was just check that it doesn't factor and reduce at the end. This one, it didn't, so I didn't write anything, but my brain went through that step. All right, let me, I don't think there's another one there, so let me, let's make up one. Because let's try this again, because I know you're loving this. Okay, let me see if I'm focused. The star of this show has to be focused. There we are. Alright, we can call it a y again, that works. Alright, what tangent, what function have we not fiddled with yet? Ooh! Secant of x over, let's do x to the 5th. Alright, don't outsmart me and bring it up, because I know you guys are really smart. Leave that guy down there, we're doing quotient rule, alright? So this is f, this is g. For some of you, you may still want to see the pattern as you learn it. Let me make it visible. Okay, so again, you're going to take the g, don't touch it, leave it alone. So when you take the derivative, don't touch the g, you leave it as it is. It's x to the 5th. Now you're going to multiply it by the derivative of f. So the derivative of secant, you remember what that is? That's secant x tangent x. You're really going to have your memorization down by the end of this chapter because you're just going to keep repeating it so much, what these derivatives are. Alright, so there's the negative in the formula. Alright, now we're going to take f, no changes to it, that's plain f. Alright, so we just take secant, nope, not red. We just take the original guy. And now we're going to take the derivative of g. So this is g again. So derivative of this guy using the power rule. And I'm just going to make a really important comment here. This is actually one of my pet peeves. You can never, ever, not in any planet in this universe, including Earth, combine this with this. So this will never become 5x to the 5th. That never works. The only way that a trig changes is if you use an identity on it. So this is its own entity. the x, the x is in the secant, like your brain is in your skull. You can't all of a sudden say, oh, I'm going to put something next to my brain, and I'm going to change my brain to 5x to the 5th, right? This is in this, so something from the outside can't all of a sudden get in something that's in something else, okay? So if you're going to alter the trig, you're going to be using some sort of identity with it. All right, so just be careful with that you don't combine these. They're not combinable. Sometimes it's hard to visualize with the trig, but that's, yeah, you gotta watch that part. All right, now where's my brain? My as I'm talking about brains. All right, now this is G in the formula. You got to square it. So we're gonna take the 5. I guess I'll use a bracket this time. You take the 5 and you square it. So it's G squared. Now, I like to pull, this is just my brain, it doesn't have to be yours. My brain likes things in descending difficulty. So my brain to my brain, this looks formatted better this way. Like that looks weird to me. This looks formatted in a better fashion. And this, remember when you've got an exponent raised to an exponent, you multiply. So we're going to multiply this. This is x to the 10. Now this answer is perfectly fine. It's full credit. And like I said earlier, the book may format the answer in a way that you did not, and you have to be aware of that as you check your homework. So I'm going to show you another way that this answer could be formatted. I actually think it's a better way. Actually, let me correct myself. This is not the correct answer. This has not been reduced. So this is actually not done, because I can see these both have x's over an x, so this is not reduced. So don't leave your answer like that. I take back what I just said. So now what I'm going to do is I'm going to take out the common factor. So let me see what the common factor is. I have 5 x's here, 4 here, so what they have in common would be 4 x's. What else does this have in common? We can see that they both have a secant. All right, so I can take that out as well. All right, so this right here is a common factor. Now let's see what's left. So from the front half, if we have 5 x's and we take out 4, that's going to leave us with 1 x. We're going to pull the secant, that's going to leave us with a tangent. Ooh, I'm already close to 13 minutes, so I can rattle away here. All right, let's look at the back. All right, we're going to take out 4 x's and a secant. That's just going to leave us with a 5, all over x to the 10. Now, this has to be in lowest form. So you could have done it the quick way, if you know what I'm saying about taking 4 from everybody. But I'll do it over here. So now I'm going to reduce the common factor with the common denominator, which I could not have done before. You can never reduce half of the top with all of the bottom. That never is accurate, right? It has to be a common factor with a common denominator. You have to take the same amount from everybody. All right, so now I'm going to take 4 x's away from the numerator, 4 x's away from the denominator. I know this is algebra, intermediate algebra, but we forget these rules because there's so many, so I try to remind you. I know you know it, you just have to figure out where it is in your head with all the other, we all have so much information floating in our brains. If you want, you could put this in parentheses if you like to, it's not necessary. Okay, gang, and then this is actually the best form of the answer, but if you have the secant distributed, that is correct too. I wouldn't mark off for that. Okay, so the thing that's really important that you have to do is, just like always, your answers have to be in lowest form, right? You guys know that from algebra, that your answer always has to be in lowest form. So the x's have to be reduced here, but whether you pull out the secant or not is up to you. It certainly is the better form to pull it out. Okay, gang, that is the quotient rule. So you've now learned the product and the quotient rule. We are moving and grooving. Okay, I'm gonna start another video again in this section. I'll catch you. Bye-bye.